Hey guys, let's get into today's video. We'll be talking about IHD, which is index hydrogen deficiency, also known as degrees of unsaturation. And here we have this equation that we use. IHD equals 2n plus 2 minus the number of hydrogens in a compound all over 2. N represents the number of carbons in the compound. Okay, so let's look at an example. Let's get a pentane, right, which is C5H12. We know that we have 5 carbons. 1, 2, 3, 4, 5. We have 2 methyls, so we know that there's 1 methyl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 hydrogens, therefore C5H12. So now let's put that into the equation. You have 2, the N is the number of carbons. We said that we have 5, plus 2, minus the number of hydrogens, and the number of hydrogens that we have is 12. We agreed on that. 2 methyls, 3 CH2s. So that would be 12 all over 2. So what do we get? 2 times 5 is 10. Plus 2 is 12. So I have 12 minus 12 over 2, and we know that 12 minus 12 is 0. So you have 0 over 2. So the IHD would be 0. And you're going to see this trend typically with alkanes. And the reason being is alkanes, they're completely saturated. As you see in this pentane, it's filled with hydrogens. It can take no more. Its IHD is 0. It cannot take any more hydrogens. It's fully maxed out. It's to the max. It has its total amount of hydrogens. It's like, hey, I don't want any more. That's it. Its IHD is 0. Okay? And if you guys don't believe me, let's take a look at another compound. Let's take hexane, for instance. Okay, let's check this boy out. You have 1, 2, 3, 4, 5, 6. C6. And then there's how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's C6. You just change the color. C6, H14, right? So now what we do is take our handy formula, 2N, N being the number of carbons, which is 6, plus 2, minus the amount of hydrogens, 14, right? All over 2. 2 times 6 is 12. 12 plus 2 is 14. No, 14 minus 14 is 0. 0 over 2. What do we get? IHD equals 0. Right? Okay. So alkanes, very, very saturated, filled with hydrogens. They can't take any more. They're like, hey, we're filled up, no more. IHD, typically 0. Always 0. Okay? So now let's look at something where the IHD wouldn't be 0. Okay, maybe like alkenes and alkynes. Those typically do not have IHDs that are 0. So let's look at an example. Let's take this compound. This compound here is called Cyclo Propane. So let's take a look at our handy formula here. IHD equals 2. What is N? We have 3 carbons. 1, 2, 3. Plus 2. How many hydrogens do we have? Let's see. 1, 2, 3, and 4. So we have plus 4 over 2. So now we have IHD equals 2 times 3 is 6, plus 2 plus 4. Oops, I'm sorry. This is supposed to actually be minus. Yeah, be careful with that, guys. Remember, this is always minus 4. This is minus 4 as well up here over 2. So we have 6 plus 2 is 8. 8 minus 4 over 2. 8 minus 4 is 4. 4 over 2. So IHD 4 over 2 is 2. So the hydrogen deficiency is 2 for cyclo propane. And this is what I was talking about. Alkenes and alkynes are very unsaturated. So the amount of hydrogens that they can bear is less than the amount that they actually hold. Okay? Let's look at another one. Yeah, let's take this for instance. This is benzene. C6H6. We know that we have 6 carbons. 1, 2, 3, 4, 5, 6. And when there's double bonds there, we always know that it's only one hydrogen attached because that carbon is sp3 hybridized. It can only hold one hydrogen. 1, 2, 3, 4, 5, 6. So I have C6H6. Take our handy formula here. So that'll be 2 carbons. There's 6. 2 times 6 plus 2 minus 6. Remember, minus the number of hydrogens. There's 6 hydrogens all over 2. It's all just basic algebra, real simple. If you just follow this formula, that's it. It's real simple. Okay, so 2 times 6 is 12, plus 2 minus 6 all over 2. 12 plus 2 is 14. 14 minus 6 is 8. So we have 8 over 2. And that will equal 4. So the hydrogen deficiency of this compound is 4. Okay. Let's see. Let's go over this one here. Actually, let me make a bit more space here. Let's find the IHD for this one. Now, we have an oxygen here, and we have this rule. Oxygens do not add to the formula. So we just continue it regular, how we did before. We count the number of carbons. 1, 2, 3, 4, 5, and 6. Be 2, 6, N. number of carbons, plus 2, plus 0, because the oxygen doesn't count. And how many hydrogens do we have? We have 1, 2, 3, 4, 5, and 6. Don't forget that guy there. So we have 6 hydrogens. So that'll be minus 6. 2 times 6 is 12. 12 plus 2 is 14. 14 minus 6 over 2. Again, for this one, we get 4. Okay. Now, let's go to this special case. Let's see, Cl. Okay, this is a halide. Halides do contribute to the formula. Remember, oxygens do not contribute to the formula, so you just add 0 there. You don't even have to add the 0. Just don't include it in the formula. Okay. However, for halides, such as let's see, nitrogen, fluorine, chlorine, what else? Bromide, etc. Those you will add to the formula. So let's see how we go about this. So we have 2N. How many carbons are there? 1, 2, 3, 4, 5, 6. 6 plus 2 plus how many halides? There's 1. So you're going to add a plus 1 there. And then how many hydrogens do we have here? We have 1, 2, 3, 4, and 5 hydrogens there. There's no hydrogen here because there's a chlorine attached. There is no hydrogen there. Be minus 5 all over 2. So 2 times 6, 12, plus 2, 14, plus 1, 15. So we have 15 minus 5 over 2 equals 10 over 2. And 10 over 2 is equal to 5. So the IHD of this compound is equal to 5. Okay. And let's go over just one more. And we have this molecule here. Okay, so we go back to our form. Oh, sorry, I forgot these here. Go back to our formula. IHD equals 2 times the number of carbons, and it should be 6, right? 1, 2, 3, 4, 5, and 6. 6 plus 2, and how many halides do we have? It's nitrogen there. So we have plus 1. Then how many hydrogens are there? It's 1, 2, 3, 4, 5. And then you have an H2 here. So that's 7. You have minus 7. All over 2. So now 2 times 6 is 12. 12 plus 2 plus 1 minus 7. 12 plus 2 is 14 plus 1 is 15 minus 7 over 2. Know that 15 minus 7 is 8. 8 over 2. And 8 divided by 2 gives you 4. So for this compound, IHD equals 4. Okay? And that's pretty much it. Just continue to use that formula. It should be fine. Oxygens, you do not add to the formula. However, things like nitrogen, fluorine, chlorine, bromine do add to the formula. Alkanes are very, very, very saturated, filled with hydrogens. They are at their max. Alkynes and alkenes, they have a little more wiggle room. So the amount of hydrogens that they can bear is less than the amount that they can actually hold. So you're going to actually get a number for that. 3, 4, 5, 6. you know, and alkanes is going to be 0. Okay, and that concludes this video. I hope it helped. Please leave a like, comment, subscribe, ask any questions if you have any, and I'll see you guys next video.